It's 1 o'clock, so let's get started. I have lots of slides to go through. Yeah, and I'm talking about Slick 2, code generation's other features, and in particular, how you can really leverage your data model to be more productive. And before we get into the Slick 2 features, let's take a little step back. What are we doing in general when we model data in our software? We take a little part of the world, a little part of reality or something fictional, and basically put that into our application, right? And it's not just in a single place. Sometimes there's a place of our code, like some folder or some files we call the model, but in fact, it's all over the place. It's like there are loads of places where the model kind of shows up. There's the Slick stuff and validation stuff and the DEO and play code and your REST API if you have one, and if you serialize stuff and other Scala code, your GUI, SQL code you write. And here's some examples like the DDL on the top left where you see like the table and all the columns, or the Slick table on the top right where you, well, table and columns again, or the case class in the middle, very similar. The form for play to do some validation, and then on the bottom left, the calls to generate HTML code. And there are a lot of similarities between all these things. So why the logical repetition between those? Like, we repeat the column names everywhere. And, well, one of the reasons, language limitations, some of the stuff we just can't abstract over. We can't just take whatever fields we have in a case class and generate HTML from that. I mean, we can, with macros to a certain extent, do some of these things, not everything. There are no type macros in Scala, and they are not coming anytime soon. Other reasons are for having these things concrete instead of kind of in a central place is that sometimes these abstractions can get very complicated. And sometimes another thing is that your team is like separated, or you want to just separate concerns, and that's why you separate that, right? But there are problems with repetition, we all know. I mean, first of all, it's kind of a bad out-of-the-box experience if you have to like write all these places to get started. And I mean, it's some effort to implement, right? But it's also effort to maintain. Whenever you change anything, you have to touch all these places to make it work. And I mean, you can have inconsistency. Scala's type system helps you, but still, it's not everything is type checked. Also, you may repeat the same bugs in several places in like very similar ways. So how can we refactor this maybe? So, I mean, we know we couldn't do that like in pure Scala. That's why we had it in the first place, probably. But I mean, in principle, we have this concept of the data model, and we could somehow derive all that stuff from that, right? But wait, wasn't that this thing, model-driven whatever, what they did a couple years back, which kind of everybody hated and was horrible? At least some of the people I talked to give me that impression. And it had stuff like this. So you have this modeling tool, and you like go do all these graphics and generate your code. Nobody wants to do that, right? I mean, we want to write code. So another thing we could do is have some Scala case classes, maybe with some additional information like annotations or something, and kind of use, I don't know, macros or something, look at that, generate our Slick tables, and, well, we don't need to generate the case classes anymore, generate the play forms, the HTML stuff, and the database schema. But wait, the database schema is in the database. There's data attached to it. And the way we handle code is basically we save it, we change stuff, we save it again. So we see different snapshots in time. We don't see how we got from A to B. But normally, the way we handle databases is we tell it to how to get from A to B. We write a migration. We can't really infer a migration from these snapshots. We can infer some stuff, like when you add a new member, you can have a migration that adds a new column. But when you have, like when you rename a member, well, was that a rename or a deleted and added field? Or when you split a class into two, how would you automatically infer just from seeing the two snapshots, like migrations for that? So that works for simple cases, and there's sometimes interactive tools to make that happen, but It's not automatic. Another way would be, well, then let's use the database schema, because that's the one we migrate. Everything else is just code. We just replace it manually in the editor, or we can just replace it automatically. Slick tables, case classes, play forms. So Slick 2 allows you to do that. And the very most simple thing you can do with Slick code generation out of the box is there's this class, Scala Slick model codegen source code generator, which you can just register as a source generator or using a manual SBT command in your SBT project. And what it does, it generates text, like it generates code, and it generates textual code. It generates a string and dumps it to a file. It doesn't use Scala macros. I'll say in a minute why. And it generates all types required for Slick queries. You can do minimal customizations so you have some decisions. You can start very, very easy with that. We chose to use textual code generation rather than macros because I think macros are not really there yet for our use case. They may be eventually. I mean, macros are code generation too, right? They're just compiler-supported code generation. What they make significantly easier is if you have like multi-stage dependencies. If you have a macro that depends on a macro that depends on a macro that depends on a macro, if you want to do that with textual code generation, you would have like a 4-stage build or something. Like if it's a macro, it's just resolved automatically by the compiler. And quasi-quotes and macros give you very early syntax checking for your code you generate. Anyways, what we don't have with macros right now is a preview of the generated code. So if you make a mistake in a macro and the code does something wrong, you can't look at it to see what's wrong, actually. You kind of have to look at the code generator or at the macro and basically expand it in your mind to see what's happening. And that can be complicated to debug. Also, with the current implementation of macros, you need at least some knowledge of compiler APIs, for example, for like term names and type names. So it's a bit harder than textual code generation. And that's why for now we go with textual code generation. And we have like a prototype using macros, but I guess that's for the future. And that's how it looks like in Slick. So you have the database schema. We use the JDBC metadata API to build a model from that. So Slick builds a model with everything it needs to know about it. And then the Slick code generator consumes this model and generates Slick tables and Scala case classes, not play forms, but I'll get to that in a minute. And there's like a template project that you can look at that implements that. So for generating other stuff than what we have out of the box, you're able to customize the code generator. So you can generate play forms and a DAO and GUI, and depending on what makes sense. And that's one of the focuses of this talk, what makes sense. And what it would look like then, you would have a multi-project SBT build, and you have basically one project for your code generator stuff, which contains a customized code generator, which could extend Slick's base code generator and then do some changes. And your main project depends on that. So the CodeGen project is built before, and then you can register some classes from there as the source and generator in SBT. And that's how it can look like if you customize Slick's code generator. First, you fetch the model from the database using this create model function. Then you pass it to the code generator, and in the code generator, you have all these methods you can override, like override def code in the generator itself to kind of add some imports, or these inner classes responsible for certain things, and you can override def code in them, or they have some other things you can override for certain features. That's like a very easy way to get started. Simple customizations and just some overrides. And I used that like as preparation for the talk to basically write a completely automatic CRUD app for Slick with Play. And let's look at that. So that's the computer database sample app. Some of you know when you used Play. It comes with Play. There's an adaptation of that in the Play Slick project. And I adapted it further to basically have the automated generation. And you have like companies and computers, and well, a computer was produced by a company, and you can add like new computers and well, all that stuff. So, and basically, what I claimed is that with just the data model, you can just generate all of what you see, right? So let's just do that. Let's just add a new table to our database. In this sample app, I'm basically using not the Play evolutions, but an in-memory database that is initialized with this database schema. So I'm just adding a new table to that. And I'm quitting SPT and restarting my app so the database is reinitialized. And what I see now, well, it's a little slow. The plumbing and the plumbing of SPT and everything in the demo app isn't perfect. There's like lots to do, but it demonstrates the code generation aspect of it. So what we see now is we have a new link persons, which was, well, taken from the table. And, well, we don't have persons yet, but we can add a new one. And, well, we added before an ID field, a name field, an address, a birthday, and some foreign keys. For the ID, it notices it's an auto-incremented field, so it just doesn't show that in the form. Name, address, and birthday, it shows as input fields, and the foreign keys, well, it shows a drop-down box for the related objects, just in this demo. So you can, well, if you don't enter the name, it gives some error, which basically also means that Slick looked at the data model. The data model was kind of propagated to runtime in a way that your JavaScript can actually look at it, right? So the JavaScript kind of, the information is propagated all the way to JavaScript to check that name is not nullable, or that the birthday should be a date, not some text. And that's like scaffolding, I guess you've seen in some other apps, but it's a bit more tricky in something like Scala, a Typesafe language, than it is in dynamic languages. And how did I implement that? Well, I subclassed the source code generator like I showed before. I overrode some of the methods. And in the methods, I have some kind of little code snippet templates using string interpolation, where I just fill in some stuff and build a large string of code and dump it to a file. And that's automatically handled by the class. And let's look at the generator a little bit. So here, that's like the app that basically runs the generator, and here's the generator extending the Slick one, and there's like some additional imports for Play and some overrides and a lot of stuff down here. I'll show in a minute how you can make it a little more readable. That's basically how you could start and how you could evolve, and at some point you may want to switch to something more maintainable. Some interesting stuff about this app, which is not related to CodeGen, it shows how you can use Play views generically for whatever model. It shows a unified controller and template for edits and insert for all models. It shows generally Slick CRUD. It shows how you can use Slick CRUD with precompiled queries, and I'll get to that later again. And also how you basically can go from dynamic to static, right? Because if you have a request via the web, and you want to handle all models at once, you just have like a string saying which model you're talking about right now, and then you kind of need to go to this model and call some Slick code, and Slick is type-safe, so how do you do that? It also shows a multi-project SPT Slick build with CodeGen. And from dynamic to tape-safe, well, basically the answer is interfaces, and sometimes you may have to CodeGen stuff for all the models, but I managed to get around that. And then I came up with this .typed helper method, but you'll probably better look at it. And what I CodeGen in this thing is case classes, Slick tables, Play form bindings and validations, Play HTML view helpers, formatters, forms, JavaScript, form validation stuff, and one-to-many relationships. And that's the impact on the app. Before it was 114 lines of code, and later it was basically 1,352 lines, adding all these features, but based on code generation. The left is the size of the code in the PlaySlick sample app, and on the right, the one I built from it. And the generated code looks like this. Basically, there's this one map from string to models, which is used for the lookup when you call up one of the pages. And then there are like the case classes and the slick tables and some place stuff and some labels for showing stuff in the GUI and some stuff that is passed to further to the HTML and JavaScript. And what else do we have? Basically parsers and relationships as well, where basically computer is related to a company, and here's some lookup stuff that gets the IDs and all that for basically populating the drop-down box. And probably this should even be refactored, because that may be interesting as well, how you basically get from a non-CodeGen app to a CodeGen app, because the history of how I came from the one to the other is there, right? Probably this should be cleaned up a bit more, but that's something that's also, I think, important, that your generated code is actually readable and debuggable and all that. But I mean, that's a demo. Let's look at a real-world case study, because I started working part-time for a company in New York, Sport 195, in April, and that's basically what we did there on a real-world code base. So they're this sports social network with like 3 pillars: athlete, fan, organization, where people can follow organizations, and organizations can represent themselves. And they're also a sports data provider or a content platform which people can co-brand or can use to populate their platforms with sports data about like the whole world of sports. And they have a REST API that is built on Scala, Slick, and Play. And they have lots of tables, and 107 of these tables with like 1,120 columns are actually mapped using Slick. And it's also shared with the Ruby on Rails legacy app. And what I did first is I migrated from Slick 1 to Slick 2, and then from just plain handwritten Slick 2 to Slick 2 with CodeGen. The migration from Slick 1 to Slick 2 took basically 2 or 3 days, and that's basically the main thing is you kind of have to split up the old top-level class table objects and separate them this way. You can look at it later. And the migration from handwritten code to code-generated code took surprisingly long. It took basically like 3 weeks with like different people working on it. I guess it was probably 2-3 person weeks actually. And that was to a large degree because of inconsistencies that turned out to be in how we mapped stuff between the database and the actual code. There were 4 cases where the columns had just totally different types, where there were loads of cases where the column was nullable on the database, but not an option in Scala or the other way around, which can basically lead to an exception, right? If you get a null but you don't expect one, or if you try to write a null but you can't write a null. In some cases, there were even columns that didn't exist at all, or that were wrongly named, or things like this. And so the first large effort was to move all of that into basically code generation and unify it. And after that, everything else on top, every new feature, something was like 1 to 3 days or something. And there were quite a lot of things. So of course we generate case classes and slick tables. We also generate CRUD with hooks for like after delete or before delete or things like this. There are typed associations and polymorphic associations where a table can be like something can be related to an athlete or an organization or something, and then there's like a discriminator column that says to which model, and also JSON serialization, deserialization. And a lot of those things existed before, but not for everything, or sometimes slightly differently, and often just for a couple of models where it was necessary so far, but kind of adding it was like constant implementation effort. And basically by switching to code generation, we get all of that for free. That's the impact that we had on our code base. So before, that's only the code that is really data model code, like queries and the DAO and on all that stuff. Nothing apart, nothing besides that. So the code that was really specific to each model in total was 15,000 lines, roughly, and there were some abstractions where several models shared like a common parent class or something, which was like 780, and we had some macros as well for serialization stuff. So in total, 16,000 lines, and by basically using code generation, we got that down to 12,000 lines. So like a 25% code size reduction. And I mean, 4,000 lines of Scala code, that's something, right? The generated code now, which basically is added, is 37,000, which can be surprisingly high. I mean, it's maintained automatically, so that's not a problem, and it's readable. A big reason why it's so large is because we basically interface between generated code and handwritten code. So often we generate base classes, which we implement in handwritten code, but it has most of the stuff already, so we can basically write abstractions over it. And then, because you cannot inherit constructors in Scala, we generate a child class which inherits from the handwritten class, which inherits from the auto-generated class. And because we have it all like indented nicely and even Scala doc comments and stuff like that, it gets kind of large, but it gets readable. That's the total setup. So we have a database schema managed with SQL migrations, like many of us. We use the JDBC metadata stuff in Slick to build Slick's model. We have some additional metadata that basically is hooked on top of it that gives us more information about the code generation, that drives the code generation, our customized code generation. And it uses it, like the code generator uses a template, so basically the code we generate is separated from the actual logic that plumbs the model and that does like abstractions over the model and things like this. And we spit out Slick tables and Scala case class and all that stuff I mentioned before. And we nicely interoperate with handwritten code. That's how our extra metadata looks like. So we have first the table, so we basically tie on the existing data model in the database. And we have stuff like what the class names should be if they shouldn't be derived by default from the table names, and we can blacklist some columns, or we can have this override default value where we can even basically generate function calls, Scala function calls into the case class constructors if we need that, because we can't get that from the database, right? Or we have this customized entity companion or customized table class that could be more customized, which basically allows us to selectively have the generated code extend handwritten code. So we don't have to like write empty customization stubs for every model, but we can basically, whenever we actually need to customize stuff with handwritten code, we can switch that on. So we only do that in the place where we need it. And there's stuff about associations. And yeah. So now I'll basically just give you a couple of practical tips what I think is a good way to use code generation and not get like into code generation hell, which some people experience maybe with the MDA approach. I mean, that's a general one, never change your generated code by hand, because you basically want to keep maintaining your generated code. You want to keep the generated code as a refactoring, basically, of what you had before. You want to be able to further refactor and further change. Well, that's a simple one, I guess. Instead, change your database schema or change your code generator or the additional metadata you have. And code gen only if you have to, because first there's an initial cost of code generation. You have to set up a complex build project or slightly more complex and a more complex architecture to allow interop between code like generated code and handwritten code. Instead, keep it simple. Like only code gen if you have to, and because generated code is often harder to maintain than handwritten code because there's a layer of indirection, right? Unless the handwritten code is very repetitive, in which case you can benefit from refactoring it. And don't like code gen rare edge cases or represent them in the model. Don't make your model like unnecessarily complicated. They are better located in handwritten code. And another reason to not use code generation when you can abstract in Scala is that, well, you can usually abstract further later, or you can interop with other stuff much easier if you have abstracted over it in Scala and Scala's type system. An example is in Scala tuples, that's not what we do, right? Scala tuples are auto-generated by well, auto-generate in the Scala code base, and we can't abstract over them. So when should you use CodeGen? As a refactoring, when you're forced to repeat stuff which you can't abstract over by other means. And the usual suspects are like entity members, basically, like if you want to have derive stuff like from the tables, or tuple sizes, or general type system limitations. For example, the constructor inheritance limitation or stuff like that. And I think it's very important to have excellent interoperability between the handwritten code and generated code. Otherwise, more and more code creeps into your generator and becomes unnecessarily complicated. So there are many ways to do that. There's inheritance, there are APIs, there are type classes, but you should care about it. Like, avoid kind of unnecessary stuff ending up in your generator. And you can use this extra metadata to make this easy and basically only, like, for example, generate inheritance when you actually want to customize. That's how we do it at Sport 195. We have, well, as I said, the base class and some handwritten customizations which inherit it, and some, well, concrete classes in the end which inherit the customized ones. Also, the code generator is not just a tool. It's part of your code, right? The main goal of the code generator is to generate your custom code. It's very much factored to your problem. So evolve your code generator alongside your code. Use it as a refactoring technique. And also put it in a version control with the code it generates. And you can start very easy. You can just use the slick code generator, override some defs, do some string interpolation. Then at some point, maybe it gets too large. You pull out the templating stuff into a separate template. We use Twirl, which is the Play template engine. So we basically have the same templates we use with Play, which is nice because it's a separate file. And well, it kind of, on the one hand, separates concerns. On the other hand, you get syntax highlighting. You can just, I don't know, if you put Sublime to Scala mode with the Play template that generates Scala code, it looks very readable. And another step you could do, if even that, if you don't really know anymore why you use the slick code generator at all, like because you don't use any features of it, just throw it away and just use the model. Just use the model Slick generates from the database and just generate stuff based on that yourself. And you should, you should put your generated sources or the schema in some way in version control. First of all, if you have the code in your version control and you have like a pull request or a commit or something, it makes it, when somebody changed the code generator, it makes it very easy to see what the change actually was. People don't have to run the code generator in their mind. They can just look at how the generated code changed. And also, since I think readability of the generated code is very important because you will have to debug it just like other code, this also makes sure that if you refactor your code generator, you don't mess up indentation and docs which you may generate and stuff like that. Also, it allows you to compile your code base without the database, which may be kind of nice, right? Or instead, what you could also do is generate basically the schema, like, for example, have a SQL script in the database from which you populate a local database and then generate the code based on that. One thing that doesn't work very well right now, but we're working on abstracting over that, is using a different code database for your generator and in production. For example, you could think of having a local H2 in-memory instance for running the code generator and then using that with a production database. But the JDBC drivers are different and they map types differently. So you'll kind of end up with wrong types. And we'll abstract over that in Slick at some point. And make generated code readable. So the generated code is really something people will look at. If it's just like this kind of weird blob of stuff, which we've seen with some code generation tools, right? People will have a hard time when something goes wrong. And actually, it's a nice thing that you have very concrete code to debug. It's easier to debug generated code than to debug a macro or to debug some abstracted code. So if it's even readable and maybe even has Scala doc that says stuff like, hey, this column, this member actually refers to this database column or something like that, it can make it rather nice. Another thing you can think about is basically exposing your schema through your web service. If you have like a front-end, back-end separation, and basically you were using Slick in the back-end, you could have like a route in your REST service or something that exposes the schema and allows frontend to also use and abstract over schema stuff. Just an idea. Yeah, some other Slick 2 features. So one thing new in Slick 2 is that we allow precompiled queries not only for normal queries and inserts, we also allow them for updates and deletes. That's important because compiling a Slick query to SQL has some overhead, and you don't want to do that on a scaling app on every single request. So you basically want to run the Slick code generator, the Slick SQL generator once and cache that result. And that becomes easier or possible in Slick 2. Also syntactically easier for the previous cases. You can look at that in more detail later. Another annoyance in Slick 1 was this auto-increment projection, where you basically, when you wanted to insert something for most databases, you kind of had to exclude the ID, and you had to do that manually. So basically you had like to write one thing that lists all your columns and another thing that just exclude the ID. In Slick 2, that's handled automatically by just excluding the ID column on inserts. And there's an alternative method which basically allows you to force inserting into the ID column if you need to. Also, in Slick 1, projections use this tilde operator to basically say which columns you were talking about. In Slick 2, you can just use tuples, regular Scala tuples, and you can even nest them. And you can even map the nested tuples to nested case class structures, like we have in this example in the bottom. Other things that are new in Slick 2, there's a prototype for query scheduling where basically you write queries that involve tables from different databases or even different database engines, and Slick figures out automatically which part of the query to run on which engine and then pulls the data and does the rest locally. It works. It's a prototype because it hasn't been practice proven a lot, and there could be better strategies if sometimes it would make more sense to basically pull little data from one database, move that to the other database and do some computation there instead of pulling a lot of data from the other database and doing it locally or something like that. Right now it just pulls from both sides and does everything locally in the end. There are like lots of smaller improvements, syntax, API, optimizer. We prepared for other backends. Right now we have a student working on a MongoDB backend. There's a guy also who implemented a Android version of Slick where, he basically replaced the JDBC backend. And also this thread local session, some of you have seen, is now renamed. There's a migration guide that lists most of the stuff in the documentation. Some stuff that is upcoming in Slick 2.1, so Scala 2.11 support. We have an implementation of insert or update. We support pre-compilation of queries that use take or drop, which wasn't supported before, which people asked for a lot. It was basically complicated because there are some edge cases in SQL which make it a little harder to abstract over. We'll have more documentation, how basically guides, if you're coming from SQL, how you're supposed to use Slick, or if you're coming from ORM, how you should look at Slick. We emulate full outer joins for some databases that don't support them out of the box. We improved the code generation and reverse engineering of the model from the database. There's an improved mechanism to basically, when you read result sets, without building any intermediate data structures, just put the data somewhere directly. And we have OSGI support. So to summarize CodeGen quickly, consider using code generation to basically scrap a lot of your boilerplate code. And I mean, it's one way to do it. There are other ways, but it works, and it's not very hard, really. But you have to try to use it wisely. Don't dump everything into code generation. Use it as a refactoring technique, basically, and well, enjoy the productivity gains you get from that. So, well, thanks to all the Slick community people who kind of reported bugs with code generation and all that stuff, to Maxime, who did the JavaScript validation in the demo, and to the team at Sport 195 for like welcoming CodeGen and basically pushing it further as well. And yeah, we're also hiring at Sport 195. If you're looking for like a Scala job in New York or potentially even remotely with an interesting project with lots of Slick and no Java legacy code and yeah, talk to me. And follow me on Twitter to see Slick updates. Thanks. Are there any questions? Yes. Yes. Yeah. Basically, that's what I suggest as like a step for more maintenance, basically to go from just string interpolation to a separate template. But that's what we do at Sport 195 as well. We use the Twirl template engine of Play to do that. Sure. Yes. So Slick's model doesn't contain any information about them. What you can do is you can use the JDBC metadata API from Java, from JDBC, to look that up in case it exposes that information. I think that depends on the database and the driver and everything. But if you can look it up, you can you can customize the code generator to basically connect to the database again and fetch the additional information and maybe store it in your extra metadata and then drive, I don't know, interfaces for that or something. Sure, you could basically generate the Slick code to make them type safe or something. Yes. Yeah, so the question is about, well, how about asynchronous and reactive in Slick? Because we don't support that right now, right? So right now Slick is blocking. What you can always do is just wrap a blocking call in the future, and that works rather nicely. There's some benefit to get if we have native asynchronous support in Slick, where you go all the way down to the drivers. It's surprisingly low as far as we know, but it is there. And there is basically the goal is to support asynchronous database queries in Slick until the end of the year. Okay. Yes. Yes. So the question is, how does the query shipping and distribution work at the moment? Right now, it's very simple. It just looks at what part of the code depends on exclusively on one database, and then it runs that part there, and what code depends exclusively on the other database. It runs that code there, gets all the results, and runs everything else locally. Of course, there could be other strategies depending on your data that are more efficient, but we don't implement them at the moment. Any more questions? Yes.
How did you handle the update of the schema after the generation of production? So you have changed the schema, and on the production you should use something like alter or something like this. You write them manually or it's generated?
So we migrate the database schema just like we always did using SQL migrations. And then we basically generate our code freshly from that. So personally I think that's the strategy that works most smoothly, because the only thing you need to do is write migrations, rerun your code generator, write migrations, rerun your code generator. And you would write those migrations in any case. Yes.
Is there any helpful code generation for one-to-many or many-to-many?
So the question is if there's out-of-the-box code generation for one-to-many or many-to-many. So out of the box with Slick, no, but I think actually that depends a lot on your project. And it's not hard to add. It's a couple of lines basically expressing a one-to-many relation or a many-to-many relation in a Slick query, like in a SQL query, but in a Slick query is just a line of code or two or something, right? And then abstracting over which things you actually join is rather simple in the code generator. Just put placeholders in what the table names are and run the generator for it. So I guess we may add some stuff to the out-of-the-box experience at some point, but in practice, probably it's more beneficial to kind of factor it to what you actually need. Any more questions? Yes.
Have you looked at the Scala meta, the thing that the macro team they're working on using for the macros? And can it be used instead of the textual generation? What do you think?
So the question is if Scala meta can be used instead of textual generation. As far as I know, there's no change of plans regarding type macros or annotation macros or something in Scala meta. It's still unclear if it comes to Scala. The Scala meta focuses more on the one hand on making current macros more usable and more stable, because it doesn't expose internal APIs or public versions of internal APIs anymore, and it can go further because the ASTs are more factored to the use case. And another aspect is basically attaching ASTs to the Java bytecode to like cross compilation unit boundaries. But that's orthogonal to the code generation stuff. And I think what needs to happen to make it easy to use is really having a textual output of your macro for debugging. There's some work in this direction, though, but we'll see when that is there. Yes.
Any model to describe your presentation? Because if your code generation based only on your data, for one entity you can have few views with different lists of count and so on. How did you solve in your case?
Yeah, so the question is, so the demo app has all these very generic cases, but in practice you have a lot of very specific cases for your models. That stuff you should write by hand because it's all different. Or if there are commonalities, you can abstract over it. There's no need to generate very specific cases automatically. If they are specific to the one model, write an individual route, call your Slick stuff, do it like you would have done it before, but enjoy that the Slick stuff is already there and that you may use some generic auto-generated interfaces to operate like over associations and things like this. Yeah, that's really a big point. Like, try to keep code generation contained to where it's really necessary and helpful. Don't let it kind of creep out into parts of the app where it doesn't really help. All right. Thanks a lot for the attention.